We're going to do that table with the Google Sheets, and so hopefully this will help us kind of remember the pattern that we did here with the equations, how the equations tell us the pattern, and also set up the sheet that we can maybe calculate for different times, not just every second. So if we start up our table first, we can go in here. We have time, and whenever you're doing a spreadsheet, I always put the units in right away. So this is time in seconds. And then we have the position of the girl, and that was in meters per second. And then we had the position of the bus. This is also in meters. Position of the girl is not meters per second. Position is going to be meters. All right, and then we also, to find out the position of the bus, since it was more complicated, we used an equation that said we had to find out the velocity, the average velocity of the bus. This will be in meters per second. And then we also found the instantaneous velocity, or a lot of times we just shorten that to velocity, the instantaneous velocity of the bus. So this is what the speedometer would say at any point in time. What is the actual velocity of the bus? And those are the ones we use. We also had acceleration of the bus. I won't put it in here since it was constant at 1.5 meters per second. But we can kind of think about how we want to do this. So time, let's reenact what we did initially. We did this to 3 to 4 seconds. Now the velocity of the girl, we said she started at 0 position. The bus started at 10. The bus started with a velocity of 0. Okay, and now the girl's traveling. Every second, her velocity, her position goes up by 5.5 meters per second. So I could say the cell is going to equal, it's going to equal the position above the previous time plus 5.5. Okay, and we can actually fill that down. And now we get to 22, which is just like we did before. So this pattern is going through here. In the same way we can find the velocity of the bus, it was going to equal the position before times plus 1.5, because its acceleration was 1.5 meters per second, which means that every second it'll go up by 1.5. Okay, the next part we did was we had to find the average velocity. So we said it's going to be equal to I'll put a parenthesis here because we want to do the addition first, the velocity at the beginning of the interval plus the velocity at the end of the interval, and then we divide that by 2. All right, and these were our average velocities. Okay, and then we found the position of the bus. So the bus is going to be equal to the position of the bus before plus how far it went during that last second, which is the average velocity. And when we fill these down, we get to 22. And now we want to make this better so that if we go to, let's say not 1, but 0.5 seconds, we go up by 0.5s, that all these will change. However, if you notice when I'm putting these in, nothing is changing in our graph. And the reason why is when we did these first positions, we went up by 5.5, we went up by 1.5 every time. We were assuming that 1 second was our time step, so our delta t was 1 second every time. So let's put these times back and then try make this equation a little more robust. So the change in position, remember from our equation that velocity, the average, is equal to the change in position over the change in time. Now if the change in time is just 1, then the change in position would be the average velocity, and that's what we did before. But now since we can have different changes in time, let's do a little bit of algebra here. If we multiply both sides by delta t, so we bring delta t up here, we bring a delta t over here. Then when we rewrite this, we could say the average velocity, delta t, is equal to delta x. So now our change in position is going to be the velocity multiplied by this change in time. So let's put that into our spreadsheet so we can do that together. So instead of just the position of the bus is going to be its previous position plus the velocity 5.5, I want to multiply by how much time goes by. And how much time goes by would be the time at the end of the interval minus the time at the beginning of the interval. All right. Now this time change is going to show up later again, so I'm just going to copy it now. We can fill this thing down. All right, so no change because our change in time was all 1. Um, but now we can also put this in here. This is going to be multiplied by the change in time, so I'll put that in there. The same way too, the average velocity, that won't change, but the velocity bus is going to go up by 1.5 every second. Now I have formulas here for this one. I got that in there, and also for this one, got that in there. I can do a shortcut, and I can fill all these down at the same time. If you want, you can do one at a time like that, or if you use the keyboard, you can highlight all of those and then Command D or Control D if you're on a PC and fill them down. Now nothing changed here because we didn't change our number scheme. But let's look here now. If instead of going up by 1 second, we go by half a second. Now we have these numbers are changing here. All right. So at 1 second, we're at 5.5 and 10.75. And if we look back on our original problem here we are at 1 second, 5.5 and 10.75. And then at 2, we're at 2, 11, and 13. So if we go back to our sheet, here we're at 2, 11, and 13. And now we can continue to climb up this 3, 3.5, 4. And it becomes very easy to extend these formulas down. So I'm going to fill down again, Control D, and you can see we ended up at the same place. But now we're getting a more detailed picture. We're getting a lot of numbers here, and sometimes when you have this many numbers, it's a lot easier to look at a graph. So I'm going to graph this now that we have more data points by inserting a chart. Here again, remember we're always going to choose a scatter graph so we can see the points. We don't want to connect them with lines yet. And then we're going to make sure that the x-axis is our time, and we go down here, and then we just want to graph the bus and the girl, so I'll get rid of this time there, and now we have 2 points here. Okay, so now we can look at this in a little more detail here. All right, let's shrink this off a little bit here so we can squeeze it in there. All right. So now it looks like they're getting very close together here, but it's a little bit hard for us to see. We could do this. The spreadsheet's very fast at calculating. We could do lots of things together. But before we do that, I just thought maybe we should make this, our pattern here, a little bit easier to handle. So we can do some things like we can insert a cell here and insert one above. Maybe I'll insert 2 above here. And let's say I'm going to write in here delta t and put equal, and I'm going to put a value here. I'm going to say I'm going to go up by 0.5 seconds. So here, now where I'm adding on, I want to start at 0, and then I'm going to make this a formula. So I'm going to say this is going to equal the position before plus my change in time. Okay, and so now I'm going to add on 0.5 seconds every time, and now let me change it. Except now we have a problem here because here we added B1. That's good. That's the cell we wanted. But now if we look in here, now we're adding a B2. We don't want to add a B2. We want a B1. But we do want to go to the next thing, A5. So the way we get around that is by adding a $ in front of the 1. And this $ locks the index. So it's not going to change as we fill the formula down. So now when I fill that down, you can see that it's always the previous time plus B1. All right, now this makes it really easy. I can say if I go up by tenths of a second, it just calculates through there. Of course, now a tenth of a second, I'm only getting to 0.8. So now we got to get to more data points. So I can just go do down. Maybe I'll do 100, maybe 200. I can do as many data points as I want. The spreadsheet can handle thousands of data points, no problem. When you start getting to 10,000, sometimes your internet gets a little slow. But I don't know, I'll go to 500 here and see what happens. So I'm getting to 50.4 seconds. And now we're getting some lot more continuous motion. But if I want to zoom in, maybe I'll go 0.01. And now I'm really zooming in here. I got lots of data points, except the data points are so big it's hard for me to see what's going on. So we can adjust that graph later. But this is a review of how you can put the information that we found in our table, initial problem, how we can expand that out to a spreadsheet, and then also manipulate the time step a little bit to really zoom in and look at what's going on. Because now when we do this, if we're comparing these two numbers, does the girl catch up to the bus? We can scroll down and we can see that the girl's starting to get close to the bus. Here at 2 seconds, it was 11 and 13. We can go down to 3 seconds. It was 16.5. Now she's within 0.25 meters. And now we can see as we get closer, she's within 0.2. Ooh, they're real close. And you can see right here, they're almost next to each other. And at some point here, it looks like, oh, they're really close. Now right here, the girl has gotten past the bus. So 18.37 is bigger than 18.3667. So the girl actually caught the bus between 3.33 and 3.34 seconds. And then she was actually ahead of the bus for a while until we get to our 4 seconds that we calculated before, which happened to turn out that that's when they're at the same point. And then now the bus is ahead of the girl again. So the girl actually caught up to the bus for almost over half a second, and then she was actually in front of it. So the end of the story is, yeah, the girl would catch the bus and hopefully be able to stop and see her sister. And hopefully you guys can see here how these spreadsheets can be some tools to analyze things pretty quickly. We're going to try modify these spreadsheets, doing these little steps, these little patterns over and over again into equations that we can solve these same kind of problems without actually having to make tables every 100th of a second to find where we're going. And that'll be the next video.